Assalamu alaikum wa rahmatullah wa barakatuh. Welcome to M.I.B Multipurpose Lab. Today we are going to look at vectors, introduction to vectors. So, when we say vectors are quantities. Vectors are quantities that has magnitude. Which means size or length, and direction. So any quantity that has magnitude and direction is known as a vector quantity. Examples of vectors, we have force, we have displacement, and also we have velocity, etc. These are all examples of vectors. So vectors are quantities that has magnitude, which is size or length, and direction. Examples are force, displacement, velocity, etc. Then the symbol of vector. Vectors, usually the notations that the textbooks use are two notations. When you see a letter, let's assume this is V with an arrow on top, then this means that this is read as vector V. This notation, a letter with an arrow, or this notation, a very bold notation. So any of this, if you come across this or this is telling you that the quantity that is being discussed here is a vector quantity. Then the next thing we will look at is the representation, the graphical representation of a vector. The representation of a vector. In physics, vectors are represented using an arrow with a head. Let's assume, let's have this is x and y axis. We can represent a vector. Let me call this vector v. So this is the representation of a vector. And the magnitude or size of this vector is here. From this point to this point will give you the length of the vector v. And the components of the vector, from this point O, origin, to this point, will give you the vertical component of the vector vy. And from this point to this point will give you the horizontal component of the vector vx. This vector v makes an angle theta with the x-axis, and from point O to vector v, also to this vx, is a right angle triangle. And on right angle triangle, we know we can apply Pythagoras theorem. So we can apply Pythagoras theorem, which says hypotenuse squared is equals to opposite squared plus adjacent squared. And here is the hypotenuse. We have magnitude of v squared is equals to the opposite, which is vy. This is theta. From this point to this point is vy, which means from here to here is also vy. Therefore, we have opposite squared plus adjacent squared, which is vx squared. And by simple mathematics, taking square root of both sides, this square will be gone together with the square root. We will be left with magnitude of vector v is equals to the root of vy squared plus vx squared. This is what we have. Now, this vy and vx, which I call them the vertical component of vector v and also the horizontal component of vector v respectively. How do we obtain them? The horizontal component of vector v, which is vx, how do we obtain it? We obtain it using the knowledge of trigonometric ratio. by saying using the cos. If I say cos theta is equals to adjacent all over hypotenuse, and the adjacent of this right angle triangle is Vx, and the hypotenuse is the longest side, which is the length of vector V. This implies that this is like over 1. If I cross multiply Vx times 1, I will have Vx is equals to the magnitude of vector V multiplied by cosine of theta. This will be the formula for calculating the horizontal component of any vector. It is equals to the magnitude of that vector multiplied by the cosine of the angle made with the horizontal. Now let's look at the vertical component. The vertical component of the vector, which is Vy. To find the vertical component of the vector Vy, we use sine theta, which says opposite all over hypotenuse. And if we look at this theta, the opposite is Vy, and also the hypotenuse is magnitude of vector V. So sine theta is equals to opposite, which is Vy, all over the hypotenuse, which is magnitude of vector V. This implies that Vy is equals to the magnitude of vector V sine theta. These are the two formulas that we will use to calculate the vertical and the horizontal components of any given vector. Let's take an example to illustrate this. Let's take an example. A force of 100 Newton was applied on an object. Was applied on an object at an angle of 60 degrees with the horizontal. Calculate the vertical and horizontal components of the vector, and horizontal component of the vector, full stop. And also, this is what we have. An example created to illustrate what we've learned, to see how to apply these two formulas to get the vertical and horizontal component. So to solve this simple problem, we write our solution. The force of 100 Newton, which means the magnitude of the force F, is equals to 100 Newton, makes an angle of 60 degrees. Theta is 60 degrees. So now all we have to do is find the vertical component and the horizontal component. The vertical component, let's call it Fy, since the force is F, and the horizontal component, let's call it Fx. Now how do we find them? We have theta and we have the magnitude. All we have to do is use that formula. Vertical component Fy always goes with sine. It's equals to the magnitude of F sine theta. And this is equals to magnitude of F is 100 multiplied by sine 60 degree. And sine 60 degree is a spatial angle which is opposite over hypotenuse. We have root 3 all over 2. Therefore, I have 100 multiplied by root 3 all over 2, which is equals to 2 here, 1. I can say 2 here, 50. This is equals to 50 root 3 Newton. As simple as that. Now to find the horizontal component, which is Fx, is just equal to the magnitude of F cos theta. And this is equal to the magnitude of F is 100 multiplied by the cosine of theta, which is 60 degree. And this will be equals to, because 60 is still a spatial angle, and because it's adjacent all over hypotenuse, we'll have 100 multiplied by 1 all over 2, because 60 is 1 over 2, which is 0.5. 2 here 1, 2 here 50. I will be left with 50 times 1, which is 50 Newton. Therefore, I can conclude the vertical component Fy is 50 root 3 Newton, and also the horizontal component Fx is equals to 50 Newton. So this is the end of the introduction to vectors. Thank you, and don't forget to subscribe for more videos.